All right. Show of hands out of the 6 people in this room if you've heard of Kafka before. 1, 2, 3. Is that 4? 5. Okay. Maybe I actually don't need to cover the 10 slides saying what Kafka is, but oh yeah, the 100 people. Hi, how you doing today? So, I mean, I don't know, everyone knows the LinkedIn story. Basically, they invented Kafka because they had a lot of stuff talking to each other, and they wanted a simplified architecture, unified log, right? Beautiful, elegant, simple solution. So, yeah, they have a cluster of about 1,400 brokers, 1.4 trillion messages are all Avro encoded, and they use it for basically interconnecting different things. So why would you consider Kafka? Well, I think no one in this universe wants monolithic architectures anymore. Everyone wants a microservice-based approach. People want to write Kubernetes containers. People want to write simple, modular solutions. So obviously there are some advantages to microservices, right? You can distribute your entire workload. And if you want to do a microservice-based architecture, you need a event-driven system. And event-driven systems are very good for business because you can have multiple divisions with multiple databases, multiple data systems talking to a centralized distributed platform called Kafka. So what is Kafka? Again, most of you actually know what it is, but you have topics, brokers, clusters, zookeeper, topics, partitions, records, etc. So this is kind of what a Kafka cluster looks like, minus your zookeeper. So just forget about zookeeper for a second. But you have the producers which send data to the Kafka cluster, which go to topics, and every topic is composed of one or more partitions. So Kafka messages always contain, a key and a value, and then some metadata. And metadata is something that either you can manually create, or you can just let Kafka do its thing and put it where it belongs kind of situation. Here's another diagram of Kafka. So producers push to Kafka, and consumers pull from Kafka. So it's a pull-based architecture, not a push-based architecture. All right, so let's talk about the subject today, which is how to preserve your data order in Kafka. I know if any of you have ever worked with Kafka before, you might have something where, So messages are sent by a producer to a particular topic. However, data in that topic is guaranteed to be ordered only in that partition. So if you have like a 5-partition topic, all your data is guaranteed to be ordered in just one of them. That's kind of a way of seeing it. And a consumer instance will only be able to see records in the order they are stored in that partition in general. So this is kind of what it is, right? All the data goes in order on the topic. Producers write to the end of the topic, log segment in a partition, and consumers read there with different metrics for offsets. And here's the anatomy of the topic, right? So all your data is essentially going to partition 0, 1, and 2. Now if I had 3 consumers, they're going to each read their own partition. Or worse, if I just had one consumer reading from all of these, they're going to get all the data in partition 1, then all the data in partition 2, then all the data in partition 3, in that order. That could be a good thing or it could be a bad thing. It really depends upon what you planned for. So what happens if you send data to many partitions? So I'm just going to create a simple partition. By the way, I could open up a terminal and do this, but the command's right here. You create a topic, 10 partitions. 10 partitions. Now what would happen if I were to simply send it the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? What would happen if I spun up one consumer and had it read from the beginning of that topic? Set the offset to earliest. What do you think would happen, Mark?
How many partitions are here?
10. One consumer. What do you think would happen? I'll show you exactly what will happen. Your data will come out in some random wishy-washy format because when I sent the messages, there was no key. There's 10 partitions. So that's why the data here is going to come out like a data pile of junk. So, yeah, there you go. When you're a producer, you're sending your data to all these nice, organized 10 partitions. Each one has its own number. And when a consumer subscribes, they're randomly assigned partitions. So what happens if you send data to one partition? We just create the same topic with just one partition. And we send numbers 1 through 10. What do you guys think happens? There you go. Exactly. One partition. Kafka guarantees its data in order for a single partition. What happens if you introduce the concept of keying? That's right, it does kind of this stuff, right? So messages sent by a producer to a particular topic partition will be appended in the order they are sent. So all messages with the same key go to the same partition, always. So suppose we want to send 4 messages to a Kafka topic with 2 partitions. We have 4 keys: Costco, Walmart, Target, Best Buy. The keys are hashed and distributed across the cluster. Right? Now suppose you want to send 4 messages to those 2 topics. Where do you think they're going to go? Where is Costco going to go? Which partition? 1? Okay. What about Walmart? Okay. Target?
2.
Best Buy?
2.
There you go. Pretty straightforward. What if I add one more partition? And then what if I do a rebalance of those partitions? It'll distribute the data nice and evenly. Not this doesn't happen automatically, by the way. You have to, run a command and stuff. But if you set it up at the beginning correctly, this is how your data would look. So we're going to send 4 more messages to a Kafka topic with 3 partitions, right? Costco, Walmart, Target, Best Buy. So everyone, take a look at the previous diagram. Lock it in your brains, okay? Where do you think Costco is going to go? Where do you think Walmart's going to go? Target. Best Buy. There you go. Does this look like a balanced? No, it doesn't look like a balanced. You have a lot of log segment files in partition 1, but partition 2 and 3 would look pretty light. So in this situation, you want to make sure that the number of partitions matches the data distribution you anticipate. All right. So how do we make sure our data is always sent in the correct order? So messages sent by a producer to a particular topic. Okay, I already read that. So here's kind of an architectural diagram of what a Kafka producer actually does, right? Producer record is like a method to create a producer record. So if you're writing some Java code, you do producer record, you give it a topic, and a value you're going to send it to. Now optional to there is a key. Always send a key. You do have the option to explicitly write data to a partition. The producer class will then serialize it, either using Avro, JSON, byte array, if you're using like a mirror maker. And the partitioner class will assign the data to partition 1 or partition 2, which will then try to talk to the broker. And if there's anything, it'll try to retry or it'll throw a record. So here's a nice little workflow diagram. So in the old school days of Kafka, you would actually kind of tweak the setting which is called the maximum in-flight request per connection. That's a mouthful of a word, but let me explain it. So basically it sets the retries parameters to non-zero. And when you have this parameter, max in-flight connections, that means you could have like more than one asynchronous thread running. And if one of them fails and the other one goes through, then your data can go out of order because the first message failed, the second one went through, then the first one goes, it'll pop in here. So usually setting the retries to 0 is not an option in a reliable system, so if you want to guarantee the order, set the maximum number of asynchronous requests to Kafka to 1. Now this is kind of an old school recommendation, but it works. So, Kafka delivery guarantees. At most once delivery, it guarantees that a particular message can be delivered once or not at all. There can be a loss of messages, but a message can never be delivered more than once. At least once delivery guarantees that a particular message will always be delivered. It can be delivered multiple times, but there will never be any lost messages. Then there's exactly once, right? And that guarantees that all messages will always be delivered exactly once, and exactly once does not mean that there will be no failures or retries. They are inevitable. An important thing is that the retries succeed. In other words, the result should be the same whether it has succeeded, processed exactly once or not. So, what is exactly once delivery? So, independency on the producer side can be achieved by preventing messages from being processed multiple times. This is achieved by persisting the message once. So if independency turned on, Kafka message gets two things, a producer ID and a sequence number. And the producer ID is completely transparent to the users. And the broker will automatically deduplicate any messages sent by this producer, ensuring independency. Okay, so then you also have partitions, which will ensure that each message gets processed exactly once. Transactions can be used. The transactions have an all or nothing approach. They ensure that after picking a message, that the message can be transformed and atomically written to multiple partitions and topics along with an offset of the consumed message, which is the transaction coordinator and the transaction log, which maintains a state of atomic writes. Then you have a consumer. If a consumer is transactional, then we should use the isolation level, which is read committed. This ensures that it only reads committed data. The default value of the isolation value is read uncommitted. So if you wanted to enable end-to-end transactions in Kafka, this is when you use exactly once delivery. All right, so here's a nice little complicated workflow. Step 1, yes, which is a register, middle of the screen. So it registers a transactional ID with the coordinator. Step 2, the coordinator bumps up the epoch of the producer ID, so the previous instance of that producer ID is considered a zombie and fenced off. Step 3, the producer adds a partition with the coordinator when the producer is about to send data to a partition. Step 4, the transaction coordinator keeps the state of each transaction in its own memory. Step 5, where's step 5? Down there, bottom left. Step 5, the producer sends data to the actual partitions. Step 6, the producer initiates a commit transaction, and as a result, the coordinator begins the two-phase commit protocol. Step 7, which is on the prepare side, is where the first phase begins, and the coordinator updates the transaction log to prepare commit. Step 8, which is at the very top. The coordinator then begins phase 2, where it writes the transaction commit markers to the topic partitions that are part of the transaction. And after writing the markers, the transaction coordinator sends the transaction as committed. Wow, that's a lot of steps. So this is kind of the diagram of how the exactly once semantics works. So to implement transactions, you basically ensure that the number of messages produced and consumed are atomically. You basically have the transaction coordinator, which sits between the consumers and the brokers and the producers in the transaction log. You have the transaction log, which is literally just, working for the transaction coordinator. And you have the notion of controlled messages, the notion of transactional ID, and then we finally introduce the notion of producer epoch. So the transaction coordinator, it's similar to a consumer group coordinator that each producer is assigned a transaction coordinator, and all the logic of assigning the producer IDs and managing transactions is done by the transaction coordinator. So a transaction log is similar to the consumer offsets topic. The transactional log is persistent and replicated record of every transaction. The transaction log is a state store for the transaction coordinator with the snapshot of the latest version of the log encapsulating the current state of each transaction. So control messages are special messages written to user topics, processed by clients but never exposed to users. They're used, for instance, to let the broker indicate to the consumers if the previously fetched message has been committed atomically or not. So a transactional ID enables users to uniquely identify producers in a persistent way. Different instances of a producer with the same transactional ID will also be able to resume or abort any transactions instantiated by a previous instance, so you can roll back or commit forward. And then finally you have producer epoch, which enables us to identify if there is only one legitimate active instance of a producer with a given transactional ID, and hence enables us to maintain transactional guarantees in the event of a failure. There's one more interesting concept which I'll cover here. It's not in my slides, but it's a new thing that came out in Kafka 2.3.1. I want you only to pay attention to one thing on the screen, because it's not on my slides and I just thought of it now. You have a topic, you have 10 partitions. In Kafka 2.3.1, they've introduced a feature called sticky partitions. What this means is a consumer can be guaranteed to always be reading from that partition, or always read from this partition. This has solved two very important things for the industry. One is you don't have the rebalance issue. Everyone's had to deal with a rebalance before. It's pretty annoying. But the thing that gets me excited, very excited, is that consumer will be reading from the same partition all the time. Wrap your head around that for a second, because if you do something like sticky partitions, that also guarantees the consumers will be reading guaranteed order for that partition, because they're always reading from a partition, not just a topic. This is not in my slides. Whoever's watching in the recording will have to remember that, but there you go. All right, guys. I prefer interactions, so this concludes my talking point. Let's answer any questions you have. Let's make this fun.
You're going to be uploading the slides, correct?
Yeah, they're already uploaded. Come on, go ahead, come on.
So in that last case you were talking about?
Yep.
Where you're just reading from one partition, and if we'd sent the data to the 10 partitions, would it just get one of the values?
If you had 10 consumers,
Yeah.
yeah, it would
If I just
only
had
read
one
one number though.
consumer-
It would only read one number.
Yeah, if I just had one consumer, would it just read one number?
I think so. I think so.
Fascinating. Okay, cool.
Kafka is a wonderful world of whatever you want. It's very, very flexible. Go ahead.
Can you talk to some real-world applications, how Kafka is used, and maybe some examples of how I would go about using it?
Yeah, so Kafka is the ultimate microservices architecture. This is kind of like the diagram in a nutshell that enables it, right? You have different divisions in your company that handle ordering, billing, inventory systems. They have like legacy, or well, I don't know if it's legacy, but an Oracle database. They might have a Mongo. They might have a MySQL, a Redis, a Cassandra, all sorts of junk. And you need to somehow centralize all these processes and talk to different divisions without going through managers or whatever, sending emails. But, we're engineers. We engineer solutions. So what's nice about Kafka, it provides a standard gateway. Because Kafka doesn't care about the format of the data you send it. It's literally just, log segments and bytes. If this was SQL, you'd have to write SQL. You'd have to write stored procedures, all this stuff. Redis is in memory. You only have so much memory. Mongo's amazing. I love Mongo. I don't know. Some people don't like it. But Kafka's good because it's a distributed platform. So if you need to horizontally scale, it's designed from the get-go to be pretty much leaderless and homogeneous. So it'll just scale, infinitely if you plan things accordingly. Did I answer your question? Okay, go ahead.
One thing. Sorry. My company actually does use Kafka as
Nice.
part of our data stack, although we do at least once because we dedupe. But one thing that can always be annoying also, that's like another small gotcha, is obviously, assuming you care about the data going into Kafka, you're probably going to have a replication factor, which also means you need to be very careful and make sure you tune your minimum in-sync replicas, as well as I don't remember the parameters off the top.
No, you're correct. You're correct. When I give demos, sometimes I like to switch off brokers, and if I don't tweak that in-sync replica to be like 1, it's usually by default 2. So I'll kill 2 servers, and then I'll start sending messages, and I don't know why it's not going through, because the in-sync replica is not low enough. So if you want to survive failure and recover faster, lower your in-sync replica. But if you want to make sure your data is replicated fully, best practice says to match your in-sync replicas with your replication factor. But whenever I give a demo, I try to reduce that min-in-sync. Yeah, cool.
But it's definitely like a small gotcha where it's also like a performance gain for resilience gain. And of course, your priority, if you're like, okay, fine, I don't care if I lose 1 in the case or a few small stack if things die, or another case like, no, this is financial data. I can't lose a single one ever. I'd rather the system have to just freeze back up until I get it back up. You have to actually make the decision on the ordering.
So another thing that one of my clients is doing in Chicago, major financial exchange, they actually had thousands of topics with single partitions. I know, right? But it worked for them. They could, go ahead. Yeah, pass him. Yeah. Guy with the motorcycle hat,
That leads
go.
into my question, which is, can you talk about a philosophy or methodology for configuring your partitions? How many you would want?
Yeah, so I'll tell you what I advise people, and it's contrary to what most published information. You want at most 1 partition per CPU in your cluster. I mean, that's it.
Our philosophy at Ticketmaster, we use Kafka heavily, is you need only 1 partition.
He's got it. He's got it.
And period. And then if you start to see that you have problems, then you might go to 2. We had this problem where internally we had one team had configured a Kafka topic. This is 2017 Kafka.
Nice.
And they had 15 partitions. But they needed it because they were recording every single thing that everybody did on our website. We have 80 million unique viewers per month.
Wow.
And so there's a lot of activity on the website. So that needed 15 partitions, 16 partitions. The problem was that other people started to adopt Kafka in the company, and they just whole hog copied the config. And so now you had these data producers that were producing maybe at peak a couple hundred messages per second, and they needed at most 1 partition, maybe even half a partition, frankly. And you can't have half a partition, but they just didn't need more than 1. And so they were like, why are my messages behaving so weirdly? What's going on? And so the answer is 1. You need 1. And
I actually have an example of that when we were first setting up the Kafka partition, because I was trying to figure out the configurations, and I'd never touched Kafka before.
There you go.
And some default somewhere is 64 is a great number.
What?
Yeah, I
Oh my
kid you not.
God.
I wish I was making that up. So it was, and I was like, I guess, sure, whatever. Well, what we do with it is we just use it as a transit store, so we then ship it off to S3, and they get labeled, so each partition becomes its own file of a segment. We don't entirely care about order because they're sorted in our method of ingesting it.
That's good,
so
yeah.
So we do dodge a lot of the normal pitfalls that your talk is talking about addressing, but we dodge it in a different manner.
That's
But
good.
here's the penalty here. So whereas if this had been one partition, which wouldn't work for us, but if it had been one partition, then we would have had one file uploaded to S3 every 5 minutes or 2 minutes, depending on your rate. Well, there were 64. Well, there's a certain amount of overhead when you need to download this data out of S3 per file, as well as listing it all out. And maybe it made some things that should have taken 10 minutes take closer to 5 hours until we had to shrink it all back down. So it's very important to figure out what you actually need as opposed to what some random recommendation is somewhere, because you'll get these recommendations. Yes, your Zookeeper node needs 16 gigs of RAM. And I'm like, our Zookeeper node I think has 4 gigs, and I've never seen that thing work hard a day in its life for Kafka, because we gave it its own special stack because I don't trust it not to knock something else over.
Oh yeah, I mean back when I was doing Kafka, all the messages were stored in Zookeeper, and it was just so interesting to like figure that out. But that's like one of the things they changed. I was glad they did. Yeah.
We actually had a problem last year where somebody had also managed to obtain the 64 partition default somewhere.
Oh God.
And so there was this team that we were dependent on. I work in fraud, and we were dependent on this upstream team, and they were producing. This is one of the reasons why I thought this talk was so interesting. Is that they were producing the data, and it was a particular type of data that had to be delivered very timely. And their SLA, their stated SLA, was 5 to 10 seconds, which was like that. Kafka should be able to like super easy to handle that. What was happening is when we actually started reading things, if you read using like Kafka Cat or the Avro consumer or whatever, whatever consumer you have, just sort of out of the box consumer, we were seeing, within 5 seconds, within 5 seconds, within 5 seconds, 20 minutes old, within 5 seconds, within 5 seconds, 40 minutes old, within 5 seconds, 2 years old, within 5 seconds. It was just like, what the hell is going on? And it turned out that because they had spread it out over 64 partitions, some of those partitions would just sit and wait until they reached a certain capacity before they published their messages. And so some partitions were kept up, and many partitions were lagging by a great deal. And because they were lagging by so much, they couldn't even hope to keep up their SLAs, right? And so it became a huge engineering problem. We just ended up having to switch to a different team to consume from. So start at 1. That's like you need 1, and then you go higher.
So I think it's way better than my advice, which is usually like 1 partition per CPU in the cluster. But 1 partition, that's perfect. You guarantee your order, and it's usually fast enough.
The only one thing I will say on the partition, because we have disk space limits on them, is do you realize you can only split your partition is also your division? So if you have 1 partition, that means each server must have the complete copy of all of your data sets. Yep. Whereas if you have 2 partitions, potentially that could live on 2 different servers. So, it allows you to divide up your data. So you do need a balance there as well. The last thing on partitions on why you might need to increase it.
Okay.
But you have the replication factor.
Yes.
Right, so if you have 3 brokers and it's replicated, then even if a broker goes down or your one machine goes down, you can still consume from the other 2.
Yeah, but I mean, it's just having if you only have 1 partition, then it's 3 copies of 1, whereas suppose I'll have 4 boxes with 3 replication, or sometimes I have to tune it down, whatever reason. But so then there's any box only has about 2/3 the total data, so it lets them have a little more disk space. I mean, it only matters if you can't have a terabyte of disk or something.
There is a reason why, if you're going to roll this out into production, you generally need at least 1 dedicated operations person. It is one of the overheads of running Kafka is that this is all battle knowledge. These are all things that we've learned because of
the hard way.
Things that have gone very, very badly wrong. And we have internal, at Ticketmaster, we actually have internal documentation of best practices that nobody pays any attention to. I'm being a little cynical. Some people do, and some people don't. And then you just have to You just have to keep hammering home, and you need to have a team that helps. Like, the larger it is, the more you have to manage it. Netflix gave a talk to us where what they do is they have everybody who wants. Is anybody here from Netflix? Oh yeah, so if they were, they could speak more intelligently about it than I can. But what they do is they actually have a system that allows you to create your own Kafka cluster and then have your own thing where you communicate within your team. And then if you need to talk to another team, then they have a larger cluster that connects to the other clusters. And it's a very complicated infrastructure. What it means is that one team can do their own stupidities locally and not screw up what everybody else is doing. But they invested a huge amount in having that level of redundancy within their organization. They also are moving petabytes of data through Kafka. We don't.
So another interesting talk I gave recently was on disaster recovery, and so Netflix had a lot of small clusters, it sounds like.
From my recollection.
Okay.
Like I said, like they'll be able to speak more intelligently to their own stuff. But.
I really wish we had someone from HubSpot in this room. They had one giant Kafka cluster, and their Zookeeper had a split brain problem. So half the Zookeepers had the metadata here, the other half had it here, and then they had this split brain issue, and it was a total disaster. They were down for a few hours. But in that case, they had one production supercluster. So generally, things I advise are small clusters, team-oriented, and then you can transport messages between them for that kind of risk.
Yes, it's usually not worth the risk. I found because at first someone wanted me to, for example, at my place, we already have Zookeeper for various types of orchestration, some configs, mostly old configs that still grumpy about, but that's a different topic. And they're like, yeah, just throw Kafka on there. It'll be fine. And I looked at, while we were benching, I looked at some of the spikes in Zookeeper load and stuff like that. I'm like, there's one problem. If this goes south, everything else that is dependent on this Zookeeper cluster is going to die horribly. Especially since Kafka, if you have a whole bunch of partitions and a whole bunch of consumers, that's a lot of connections, and these start adding up on Zookeeper. And people, especially, and even at the base level, you're like, oh, this is fine. Well, when it disconnects and reconnects, you end up with double the number of connections for a little while. So you thought you were fine at 60 of 100. All of a sudden, it needs 120 of 100 because some hiccup happened in Zookeeper or something, and now your Zookeeper is rejecting a bunch of servers, and you're down.
I once made the mistake recently where I set up just like 28,000 partitions on my laptop. It's like a little laptop cluster. Or I don't know, maybe it's a bigger cluster, maybe it's a bunch of medium-sized nodes, and I don't know. But I accidentally created 28,000 partitions, and that was a big disaster, basically. I had to like manually delete data in Zookeeper and manually delete the topics because the tombstoning method couldn't keep up, and Zookeeper was out of whack. I mean, you know.
All right. Does anybody else run Kafka in production?
Anyone else trying to learn Kafka?
Do you have particular questions? I mean, it sounds like you have 3 people who've done this, and we can. No, it's fine. No, it's like I would rather that this be, and I think Zeke would agree with me, that people learn in the session than.
I want this to be interactive. We have a lot of time together.
Well, I've known about it for a long time, but never used it. And one reason I didn't is because, well, I don't know. It's not normally advertised as a product that offers great latency, low latency. And I just ask what the opinion of that is in the room.
So you could make Kafka be incredibly fast if you turn off replication factor of 3, set your in-sync replicas to 1, you turn off, acknowledgements from the producer, and you don't use transactions. If you turn off all the safety flags, Kafka is just gonna, fly like a rocket ship. I don't know if it'll be as fast as Redis, which is entirely in memory, but that's like the maximum performance you get out of Kafka. I don't know if you guys want to chime in here.
What's your expected estimate? What do you need?
Well, I mean, trading systems. So.
Yeah, trading systems use Redis.
Yeah, actually, we wouldn't use that. We use 0MQ. I mean, that's, yeah. So it's just a layer above the socket. Or there's, actual appliance devices like Solus.
Because Redis gives you a concept, so you can actually have, think
Redis, you have to maintain, I mean, to deal with any kind of volume, you still have to maintain your own sort of backup and coherence. And, yeah, so, yeah, well,
Yeah, Kafka's
yeah,
not nanoseconds.
from what point to what point? It's in the network topology is another question. So.
Like C drivers and
No,
yeah.
it's like all along again, a network topology, which is, you know, what is doing matching, what is doing any calculations, depending on what part you're talking about. And then most of all, you know, shipping it across a wire somewhere. So that's where I just wondered if anyone ever uses it for those kinds of things. I guess not.
You could, but
Yeah.
yeah.
Okay. So.
We will score fraudulent. We will score a transaction limit for fraudulence within about 500 milliseconds on average, 170 minutes.
That's pretty slow.
And that's doing. We actually do streaming joins using Kafka streaming. I can't tell you the number of topics, but that's a little bit proprietary, but on the order of 20.
Okay.
Come on, guys. This is interactive. Any questions? Good. Don't be shy.
Yeah, I'm not using this in production or for anything at the moment, but just curious as to like how it is being used or what the best use cases or purposes are. What would be a expected time for a message to be held within the queue? Do you use it as like a data lake that they always live there forever, or
No, Kafka is
you'd
going to
expect
store
things to,
data
like, move
for
through?
like 7 days at most. That's generally the setting. And
You could set it to whatever. We have some topics that actually have retention of 60 days.
Damn.
But to your point, you then have to have a lot of disk space to hold it. So it's up to you. That's a configurable option. We actually have some use cases where Ticketmaster's traffic is very bursty, and on certain like the one I was telling you earlier, the everything that everybody does on the website, that we only have retention set for 1 day. We don't have retention set for 7, because 1 day is like redlining certain parts of the system. So yeah, that's at the topic level. Topic level sets the retention period.
We also set various monitoring on our Kafka stack. So I'd set up it's a very primitive, simple disk alert, which is if the disk space changes by more than 10% in a day, since the retention is 7 days, I'm like, start screaming at someone. So that way we can deal with it, whether it's scale up, figure out why something's flooding us, whatever. We have time early on, as opposed to the normal disk alerts of, oh, I'm over 60, or whatever disk alert someone
it's like an
says.
hour later, you're screwed, basically.
Yeah, but I mean, so that's why I'm like, okay, if disk space has changed more than 10% within a 24-hour period, I mean, usually it's in reality like 6-hour period or 1 hour period or whatever, but still it triggers an alert then, so you immediately start looking like, okay, why is there a lot more data than this cluster will be able to handle for a long period of time? So it's also very important to make sure you catch that early, because if you catch that late, rebalancing takes time. Can be a fair amount of time depending on the amount of data. So if you don't have monitoring that gets you to be aware of a problem with enough time to deal with it, your cluster may fall over before you're done. So,
To your other question, why do this? What this enables is there's a couple things there. One is that you have a producer, and the producer can be on a different team than the consumer. So the producer says, like the consumers and the producers will have their product managers, and usually what's going to happen is that there's one use case where one team says, hey, you guys are doing something. I want to know what that is. I need to know the messages that are going to come out of there. Like maybe you're doing click tracking, maybe you're doing purchase tracking, maybe you're doing whatever the hell it is you're doing, right? I want to consume that and I want to be able to do stuff with it, but you guys can just give me the data and then whatever. Like it's my job to do something with it. And so what happens is then that the producer and the consumer, the product managers generally have a conversation about what that data looks like. And you produce it on a stream. Right? The producer just starts pumping messages on the stream. You, through some either shared mechanism, you just decide the retention period, 7 days, whatever it ought to be. That's where you need to have the operations person in the middle who can help tune things for you. And then that producer should be doing things in an Avro format. And this is really, really, really critical, because what happens is that a lot of times people produce their messages in JSON because they think it's simple. And then the problem is that the producer then changes a message, or they produce a malformed message. Well, JSON will just let you dump that into the topic and it doesn't care. With an Avro enforcement, there's another server that's called the schema registry, and the Kafka brokers will say, wait, this message doesn't conform to what we know exists. So no, we're not even going to accept the message from the producer. That saves a lot of defensive coding on the part of the consumer, right? Because now the producer can do whatever the hell they want, but so long as they're compliant with their schema that has already been agreed upon, they can add new fields. They can't delete old fields. And you just add in whatever fields you want, and then the consumer can then start to change what they do at their own pace, right? So by adding this Kafka layer in between, you've got a separation between these two teams, and they can start to do things independently of one another. The other thing that you can do, especially if you're doing the keying, as Zeke described, is you can use Kafka streams, and you can do streaming joins, where you can say, like, okay, I've got one topic over here where the key is customer ID. And I've got another topic over here that has, information about that customer for whatever reason. Or you've got a, database transaction ID, and here's another database transaction ID. And then you do a streaming join. You say, like, if anything happens within a 5-minute window that shares those IDs, produce that message on a third stream that has all the data put together. And we use that extensively across Ticketmaster in a lot of different products, because then what happens is that you then have a bunch of different producer teams, and then your consumers can start to consume from different teams. The producers don't even have to be aware that the consumer is consuming it, right? And so then you can just grab as much data from as many different endpoints as you want, and then produce your own machine learning model, your own analytics, your own whatever it is to indicate something to the business, right? So that's a really powerful use case for us.
I had a couple for you here. So like this one, because you got your picture up. For your different data stores, like what are they actually emitting? Is it like, bin log type stuff from MySQL, or custom messages that are coming out? Like for like this particular one?
Yeah, this workflow, if you asked me this workflow like 6 years ago, I would have said, forget about it, that's too much work. But there's actually this wonderful world of connectors. So it's like open source stuff that a lot of different vendors have put together. So if you want to connect MySQL to Kafka, or Mongo to Kafka, or Redis, or Cassandra, you can just turn those solutions going. It's also not that hard to actually just, in your programming language to get like library for X, and then library for Kafka, read from X, produce to Kafka, and then that's it. You don't even care. It's pretty nice.
So you could also have like, your microservice might be emitting things directly.
Yeah, but you would write to Kafka first because, as Mark was saying, Avro is a good gatekeeper and, security guard for your data. You don't want to send malformed data. It's pretty easy to do that if you're like doing web scraping or anything in data.
And my second one here is, how easy is, it's not quite discovery, but if I'm producing data, and then I'm not sure if I want to keep producing that data, and I'd like to find out, it's beautiful that we're all decoupled between myself and the consumers, but I'd like to know who my consumers are so that I can tell them if I'm going to deprecate my data or change it. Is there a nice way to figure out who's consuming my data?
So at least with the Kafka stack, unless there's a connector I'm not aware about, generally speaking, all consumers are tracked either within. I don't know that they're not all entirely in Zookeeper anymore in the newer versions.
Yeah, they're not.
Unfortunately, one of our connectors still requires an older version, so I'm not 100% on the newest ones. Still waiting on that dang update, but whatever. But you can connect to the Kafka cluster itself, and you send commands to it, and you say, give me a list of consumers. Every consumer joins with the consumer group, and assuming your connections aren't set up terribly weird, so basically if you're following the actual proper way to make a connector, it will tell you the IP address or the host information of who is connected to this partition on this consumer group, or topic on the consumer group. So you can track the service that way. If you're talking about like other services, you just kind of have to track them yourself. But
So, I mean,
What's the identity?
the simplest way to track the status of your consumers is just monitoring consumer lag. So you can say you're like X number of messages behind in this consumer group. I think that's the question you're asking.
I'm just trying to find out who my consumers might be. Like, my other business group is.
Oh, so usually that's engineering best practices where you name, your topic and your consumer group and your producers. They should have a similar entity kind of thing. I would be in that approach. What do you guys do, I guess?
I think you're talking about how you ID them. Whenever a consumer joins, part of its Kafka configuration is you give it a consumer group name. So that way you're like, oh, this is Secor short store or whatever. If you're using Secor and have a short store versus a long store versus whatever. So you're like, so I need to look at the Secor short servers because that's what's acting up right now. Or not consuming for some reason, depending on your monitoring. So the name is very important there. If you use bad names, of course, good luck. But yeah.
We actually have a discipline within Ticketmaster where we have everything needs to have what's called a PRD code, and that's the project code.
Nice.
And we will actually automatically kill topics, partitions, EC2 instances. We kill anything that's on the cloud that doesn't have a PRD code because that's how we do our billing. And so sometimes people forget that, and they're like, oh, I'll just create this instance, and then you forgot the PRD code, and then your EC2 instance is dead 2 seconds later. You're wondering what's going on here, and it's because you didn't tell us who you were. Right, but that's because we have 1,100 engineers, so having that kind of coordination is necessary.
It's not by domain or IP, that's not available.
It's not really by domain or IP because you can also have multiple consumers in your consumer group that could be on different IPs.
So consumer groups are basically how you share a workload in Kafka. It's how you distribute the compute capability. And so partitions are mapped to each consumer, and depending on the number of partitions available, then that's how many consumers you can have. And consumer groups are literally applications working as a team. You can have 5 consumers each reading partitions, and they could be anywhere in the world, although it's better if they're kind of in the same location, I think. Yeah.
Where it gets interesting is I had this example, like where that you start to need to have more partitions, right, is actually your producer can be streaming along and the cluster can be fine, but then when you have a consumer, if the consumer is doing heavy work for each one of your messages, then either you need to have the consumer be intelligent about how it says like, okay, I'm going to do heavy work for this, so I need to do my own distribution of work, or you have a consumer group where you have you'd say okay, let's make this 4 partitions so that I can have 4 different consumers in the group and each one of them does something. I personally prefer the first pattern because a separate consumer, maybe not heavy at all, and now all of a sudden you've increased a lot of overhead in your cluster, increased a lot of overhead on your producer, so that one particular consumer who may be just sloppy is now causing some problems, right? But that's where you get the one CPU, handling it recommendation. Does that make sense?
Yeah. So I wanted to ask a question about Avro. I mean, speaking of, resources and latency.
Yeah.
So if you're using Avro, I guess the overhead is considerably more.
Not really. I mean, all Avro does is it encodes a message in bytes, and when you receive it or try to send to Avro in the library will basically just, on the producer, it's like just a little, if statement that basically says, does this byte array match what we're expecting? Like, does it have these attributes? Does it have these fields? If it says no, it'll say no. If it says yes, it'll go through. So that isn't relying on a server. It's just a downloaded schema rule book. It's like a rule book that you download a rule book, you have it in front of you, you look through it quickly, and you're done.
Right, but it still does add that slight bit of overhead.
It's like O of 1. It's like a simple one-time operation. It's irrelevant for performance.
Okay.
Well, even for there, it's irrelevant because it's That's kind of how I think.
Yeah, I mean, there might be a small overhead, but it's the amount of pain and frustration it will save you from some jackass
Here you
putting
go.
a malformed JSON.
For Kafka users?
Should be.
Should be.
Yeah, I mean, you can.
JSON is not common.
Well, for one client, I actually set up like JSON schema, which is like Avro, because we are integrating with, what's the name of that Node.js API? I forget. Anyway, for some reason, they needed to use JSON instead of Avro, but I made sure that they used a schema type tool. In general, I would enforce Avro schema because it's Avro's the best. I'll just put it that way.
On the Kafka side, so you implement the schema.
Avro is literally just like,
No, I know what Avro is, but you're saying you, with your JSON people, you had them set up a schema, or you set up a schema. What does that mean?
in broad terms, you can send a message in any format you want. You just need to validate it against a rule book, and that rule book is defined in JSON. Yeah.
Right. And what the Avro will do is there's a separate server that's a schema registry that tracks the Avro schemas, and when you update it, it'll keep track of that. And so you could say like, this is actually Avro schema ABC version 2, and so there's actually bytes at the beginning of the message that specify what to look for, and that's how the server. Yeah.
I mean, I had a couple financial clients, but I don't know if they were doing it for like real-time trading analysis. I think they were using it for like storing trades. Yeah.
Without getting into too much of a religious argument, is there a reason, or in your usages, why Avro over Protobuf over whatever other?
Protobuf is fine. Yeah, it's totally fine. Protobuf is like, Protobuf is like encoding messages with, I forget, it's like basically two methods, and that's called Protobuf. That's what I remember. You can use any encoding library of Kafka. That's why people like it. Like, you could do raw bytes, you could use JSON, Java objects, you could do, XML, JSON, Avro, whatever you want. Just best industry practice to like, save everyone a lot of headaches is to use Avro. So if you're hiring like a junior engineer, the right code that just sends data into Kafka, it could be like, bad data, and then that would break other work down in the pipeline.
So you could bypass any of this validation.
Yeah, of course. Kafka by default doesn't care. It's just, Mark and me who've worked in Kafka for a while, it's best to introduce something more authoritative, and then in like the more senior people go, we don't need Avro. But when you're first adopting it, you want to build that best practice advice. And when you implement it, it's just a message encoder. Like, you don't have to actually use it on every single application. You could have like one topic that's Avro, another topic that's like images, etc. You want the microphone?
No, I'm done.
All right. Come on, guys. Any more questions? A couple quiet people here.
He raised a really interesting point. Another reason why to use Avro actually is compression, because Avro is a binary format.
It compresses,
right?
like, if you were to send a JSON packet over the wire, that's a big JSON document, but Avro just like,
It's
little
like 10.
bytes.
It's like 10 to 1, depending on your data.
Imagine just you're sending a Word document as opposed to a zip file, except your Word document's big.
Yeah, I mean, if you don't have any control over, what gets put in, makes sense.
The only time it gets annoying is if, you're using like some kind of tool that can't connect to Avro. So if you're not using Avro, it's easy to read Kafka topic because it's JSON, but a lot of tooling out there makes it easy. But Avro is pretty much the way you want to go, if you can do it.
Yeah, I don't know if you guys do this. It's just like one of the tricks that I've just picked up over the years is like I have a notepad that has like commands that I've just sort of like memorized, or it's like I need to connect to this server and do this thing, and so like I'll have the like 5-line command, and it's just in that notepad, and I can just copy and paste it. I do that with Avro with Kafka because there is a Docker image that will run a command line tool to consume from a topic. And so if you're like, I'm always consuming from this topic and I want to run this experiment, and I consume from the topic and I dump it to a file.
Nice.
And it's, it's going to be like Docker run image name this, like here's the thing, here's the thing, here's the thing, like here's what my zookeepers are, here's where my broker servers are, here's where all this stuff is, here's where here's the Avro schema registry is all here. So it's like 5 lines long, and I just have it, in that copy paste thing. And then I could just sit there and listen to the topic. And that actually helps, because what happens is that a lot of people will do the standard monitoring that you put on your Kafka topic is a sort of standard, hardware monitoring, right? Like memory, disk, network, what's the last one? CPU, right? You just do that. And then lag is another one, right? But a lot of times what people will do is they'll actually have an ELK connector, right? So you have your Kafka going into ELK, and then you look at your results on Kibana, and there's very standard connectors to do that. But sometimes your connector screws up. And so it is helpful to be able to sit and listen to the topic using a command line tool, and then just say, wait a second, do I have a problem in my ELK stack? Or do I have a problem in my thing? Like it's just a very useful, handy way to debug stuff.
Yeah, the ELK stack and Kafka go very nice together, though, because you can pump Kafka data into the ELK stack, and you get your Kibana dashboard. It's pretty cool.
Yeah.
It can also be very good for having a temporary. It can also sometimes Kafka can help if you need at least in the earlier days of ELK, there's big problems where you have to make sure you throttle what you're throwing into that. In some cases, I mean, it depends on how much money you're throwing at the problem, to be frank on that. But so you can use Kafka sort of as a buffer, and you can always set your consumer that you only send these rates, and then you can, after you get your ELK stack ready, you can tell your consumers to speed up and whatnot. So it can act as a temporary data store. Also, if I don't normally care about these logs going into ELK, but you're like, oh, some crud happened. Since if your logs are passing through Kafka, assuming they're still living within it, you can make a new connector or a new consumer and go consume it and funnel it into ELK now, and it'll give you whatever the lifespan is of the Kafka, depending on how you set your parameters there. And you can be like, okay, great. Now it's in an ELK stack. I just grabbed 7 days, where normally I don't care about putting this in ELK for whatever reason. And now you just have it there.
Nice.
So it lets you it can give you some flexibility there. I mean, these are kind of oddball cases, but you never know what someone's going to end up using a tool for. So I try not to presume that even if it sounds a bit weird, that someone might find a case where no, this is the greatest thing ever for me, for whatever reason.
What Instacluster was.
Oh, yeah, well, I have pages here on what we do. Here you go. So basically what we do is we're just a scalable managed service company. So we work 24/7 on open source technologies. We don't have any licenses, and we basically solve any type of Kafka related issues that you might have. I'm on the consulting team, so I'll just go on site and write some code or look at some stuff and provide expert advice. But that's our business model.
Last question.
Yes. No such thing as last questions today, by the way.
As a very, very small team that's probably not ready to invest dedicated resources to Kafka, but we'll know, or we think that we want to use it in the future, what would be a service that you would use in the interim?
To get started with Kafka?
To get a Kafka-ish kind of level of experience or service level. Maybe not a Kafka, obviously not Kafka the product itself, but another product that's similar enough that you can kind of get your feet wet and start thinking about dealing with streaming data.
Go ahead, Mark.
I mean, so there's 2 ways you can think of it. One is Amazon offers Kinesis, which is a very similar product, and they also actually offered managed Kafka. The last time I checked managed Kafka, but this was like a year ago, managed Kafka and Amazon did not have a schema registry. So that's, to me, is a big minus, because then you can't do all the fun stuff we're saying about Avro. But I don't know if that's still true. You might know a little more. But those 2 would be that's where I got my start in learning how to do streaming.
Yeah, and then one of our competitors is a Confluent Cloud, you could spin that up, it'd have everything, you'd try it that way. Kafka's not hard just to set up. You download some Docker stuff and you can have a cluster running in minutes. You just spin up a little cluster on your laptop.
Yep. So one of the packages that I had worked on that we use for Kafka is, have anybody bought tickets like where you had to wait in line in the queue? Like there's a queue and yeah. So I worked on the team that figured out how many people should come out of the queue at any given time, right?
Cool.
Which is a huge pain in the ass. It's a whole long story. But that was all done using local Kafka, right? So I created local Kafka, I recorded on sales, and I sent messages to myself. Like you can just replay the messages back. Like you make a local producer, you replay the messages back, you have a local cluster, you have, you set your partitions up as they should be, and then you have your own consumer, and then you see how the consumer behaves. And you can script it all, right? It can all be running in Docker containers. So you just fire up all your different Docker containers using your favorite Docker manager, and then have a behavior that you expect to see of the messages. And then you can script all of that so that you can then have an integration test for your Kafka system. And that all requires local stuff. That doesn't require having a dedicated ops person or anything like that.
Also, just on the idea, because my company, at least parts of our team, are really small, or at times. But what we did, for example, when we were first, we were migrating one of our old systems to Kafka to start using Kafka. So what we did is we made it so we made it so it was side by side because we needed to compare the two. So if you have the bandwidth, and so that way you can test out Kafka without allowing it to be critical path, as long as you're careful with your code. So that's how we discovered all these problems. Like I was like, 64 partitions will make us lose hours of time. That's not okay, stuff like that. So when you do the two side by side, you can kind of have someone who doesn't need to be like, oh, I'm on point on this immediately because this is production critical all the time. So if you use it as a new thing you're watching so that you can tune, assuming you have the resources to be allowed to do this, of course, so you can like tune it over time, figure out what works for your use case, rather than trying to jump all the way in all at once. You just have to be careful, of course, in code to make sure it won't take out your project when you mess up your Kafka stack. But I'm going to assume that gets coded right.
Just really quickly, officially we are out of time. There's 30 minutes between now and the next presentation, so you guys are welcome to sit and ask Zeke questions, but we should at least give him a round of applause at our specified time.
We can keep going. I'm happy to talk about Kafka all day, and I actually do like half day, full day training workshops in Kafka, so if you want to learn it, I'm happy to provide free education on that as well. It's open to the public. Not sure when the next one is, but I usually do it like once every couple months in different places. Hopefully online. It'd be good to do it online, I think.
Yeah, and the other thing I would say, again, please ask questions, but Tess Gadwa is going to be giving a talk on really cool visualization stuff. Nice. In 30 minutes. So hopefully everybody will be here for that too, because I just saw the slides. They're pretty cool.
Do you have a question?
No, I'm good. I guess you covered all the topics.
Okay.
Wait, well, I didn't mean to cut everything short, but I did want to make sure that you guys were cognizant of things.
I'm not. These guys probably know, honestly, a lot more about Kafka than
I think
do.
the three of us kind of like are battle-tested Kafka nerds here, which is pretty cool.
Just to an extent, it's just one of like 20 different hats I wear. So
nice.
I'm not. I mean, I'm the closest thing to a dedicated engineer we have, but I'm also a cache engineer and sysadmin and deployment. It's you.
DevOps,
places,
man.
You wear a lot of hats. So I can try and answer from like the lower, like higher level. You need to remember, high level is easier than lower. Sorry.
Lower level, yeah.
I always find that funny. Anyway, sorry. But so if you have questions, provided it isn't something that's like proprietary, I'm not allowed to speak. I don't mind answering. It can be a silly question to you, but I'm sure that at some point, one of the three of us has had to suffer through it. And if you don't know the answer, it's not a dumb question. So feel free to ask.
There we go. Come on.
So this is related to Kafka, but I have a few people that I work with. I'm not, they're kind of teaching me, so to speak. I'm more of a domain guy. So they said about NiFi.
NiFi.
NiFi. Do
Ah.
you know anything about Kafka NiFi comparison?
Yeah, I do have
What can
one.
be used for?
I do have one customer. It's University of San Diego. They actually needed NiFi and Kafka from a single vendor. I don't actually know NiFi, but I do know that they can actually work together. I don't know, Mark, if you.
First time hearing those two syllables together, so.
Apache.
I didn't know that was a thing.
Pretty new, I guess. It came out because of
Well, if it's pretty new, then by this time next year, I'll have 3 talks submitted for open data track for what NiFi and using it.
It's pretty old, actually.
Yeah.
Yeah.